All right, good morning to this morning. Today we'll be looking at this question from applied electricity. Applied electricity is just the basic part of circuit theory. Usually circuit theory in Nigeria is taken by 300 level students, but or students, engineering students in their third year, whereas applied electricity is just like a foundational course that kind of prepares you for what lies ahead in circuit theory. So basically, what you do in circuit theory almost applies in applied electricity too. Applied electricity is just like a foundational course, like I've said. So a knowledge, most of the times people get to confuse both of them together. But then it's still basically the same thing, the same rules of Kirchhoff apply. Sometimes applied electricity courses go as far as employing nodal analysis and things like that. So if you are in for my circuit theory course, this might also be an important and a very brief and concise foundational course for you. So let's delve into solving this question. We have to find I1, that is this very current in the circuit below. You can see that this circuit has several branches, but then we want to be systematic in our picking, and then by doing that we'll be able to label each and every branch current effectively. So let's say there is a current in this direction. Let's call that I2, right? So that's a current entering this resistor I2, and please, I'll be labeling polarities with my resistor with my current directions. So whenever there's a current flowing into through any resistor, I'll give it a polarity. And the rule for labeling with polarity is such that current enters through a resistor at the positive side. So this is where the current enters, this is where it leaves. So here is going to be positive and here is going to be negative. So similar thing happens here. Current enters at the positive side of the resistor, leaves at the negative side, right? Now these two currents would be what I will build the whole circuit currents on. So all the whole current in the circuit will be expressed in the form of these two currents. So what will be the value of this current, if I may ask? You remember, by Kirchhoff's current law, the current entering this node is equal to the current leaving. So that means this current is the sum of this and this. So this is going to be I1 plus I2. So this current in this direction is going to be I1 plus I2. Remember, this is I2, not 12, please. This is I2. And then in that case, if current leaves here, sorry, if current enters here is positive, here is going to be negative. So remember, you have a 1 ampere current coming down, and then an I2 current passing through the 10 ohm resistor. So both of them meet here and then flows through the 25. So just like a river flowing like this and another one. So the sum of the currents of those two rivers would be what will flow through the next resistor, or the next this very load. So from here you have what will be the current in this direction. This current would be the sum of these two current. By Kirchhoff's current law, the sum of current entering the node is equal to the sum of current leaving. So therefore what is leaving is the sum of the two currents entering, which is I2 plus 1 ampere, because 1 ampere is what was quoted from that comes to the question that enters this node. So from here, what will be our polarity? Remember, current is flowing down, so it enters at the positive side and leaves at the negative side. So we've given polarity to the most important circuit part we'll be dealing with. So let's write Kirchhoff's voltage law around the loop. So the two loops to be considering would be loop 1 and loop 2. So for loop 1, we have Kirchhoff's current law around this loop. The sum of voltage drop across a loop, a closed loop, is equal to 0. That's the statement of Kirchhoff's voltage law. So from here, the rule we want to use in defining our voltage is such that if a voltage is positive, or yes, if the voltage is positive, that means we actually encountered that voltage during our travel around the loop. That's the first polarity we encounter, is the sign of the voltage. So this voltage is a 150 volt source. You could carry plus or minus, but the convention you are going to use here is such that if we encounter, because usually I personally like analyzing the circuit in in the clockwise direction. So my direction of movement is usually in the clockwise direction. You might choose a convention and stick to it. Well, that's for you, but personally for me, I do go with the clockwise convention. So I normally analyze my circuit in the clockwise manner. So that's what we'll be doing. So we'll be going around this circuit in the clockwise manner. So we'll move from here to here, down to here, and then back to where we start from, and then that's a complete loop. Now what would happen is, one, in the process of our transversion of this country, sorry, of this circuit, or while we are transversing this circuit around a closed loop, if we encounter a negative sign, we'll give that voltage. That is, if the first thing we see for that voltage source or that voltage drop across that element is the negative sign, then that would be the sign for that voltage. So this is going to carry minus 150 volts. This is going to carry plus, because remember we are going like this. So the first thing I encountered here was plus. Then this is going to carry a plus as well. Then back to where we started from. So by KVL, we apply KVL to this loop. This is minus 150 volts. That's this very one. Next is this. Next in line is this 4 ohm resistor. What's the value of the voltage drop across this 4 ohm resistor? So what's the polarity? Is positive because we encountered a positive sign. Then what would be the voltage drop? That's 4 times the, that's, voltage drop is resistance times current, or current times resistance, and that will be resistance, which is 4. Current is I1 plus I2. Then I'm done with this. I will move to this. The polarity is positive because this is the first thing we encountered. And then what's the voltage drop across the 65 ohm resistor? That will be 65 times I1. And then I'm back to where I started from. This is a complete loop, and then I'll equate that to 0. So this one minus 150 plus 4i1 plus 4i2 plus 65i1 equals to 0. So from here, I'll group the I1 and I2 together. I4i1 plus 65i1. So that will give us 69i1 plus 4i2. Then take this to the other side. You have this to be equal to 150 volts. So from here, we call this equation 1. And then we're done with this loop. We move to the next loop. The next loop, we apply KVL round the loop. Remember, we are going in the clockwise direction. So for loop 2, we apply KVL around the loop. Then we have remember, we'll go like this, and then back. Then the sign of this voltage source, since we are going in the anti-clockwise direction, is going to be minus, because this is the first thing I encountered. Remember, I'm going like this, so it's minus 65 multiplied by I1. That's resistance times current. Then move to this one, that's going to be plus, because if you go like this, the first thing I encountered for this voltage drop is a plus. That will be 10 multiplied by the current passing through that branch is I2. Then I'm done with this branch. I'll move to this branch. What's the voltage drop? The sign is positive because that's the next voltage sign I encountered. Then what's the voltage drop? That's going to be 25 times the current, which is I2 plus 1, and you equate everything to, because I'm back to where I started, equate everything to 0. So you rearrange this circuit. You have minus 65 I1 plus 10 I2 plus, open this bracket, you have 25 I2, then plus 25 is equal to 0. So from here, we regroup I1 and I2. This is minus 65 I1, then 10i2 plus 25i2, that would give us 35i2. Then take this to the other side. You have it to be equal to minus 25. And then you call this equation 2. You collect equation 1 and 2. You should collect that in matrix form, because in electrical engineering, like I would always say, its matrix approach is usually favored. So if from equation 1 you write it in matrix form, that will be 69, 4. And then for equation 2, you have minus 65, 35. And then you have this being multiplied with I1, I2. And then this is equal to, here you have 150. Then here you have equal to minus 25 from equation 1 and equation 2. So these are your matrix equation. If you solve this, you find determinant of delta 1, delta 2. You could use several methods to solve this, which I'll leave out to you, because at this stage it's believed you should be able to solve a simple 2 by 2 matrix. If you solve this, you get your I1 to be equal to 2 ampere, and then your I2 to be equal to I2 is equal to 3 ampere. Like if you solve for this, you could as well solve for this with your knowledge of simultaneous equation, I think substitution method, elimination method, and such and such and such. So that's it for this video. Thanks for watching, and like my video, comment, let me see your inputs in the comment section, your observations, your corrections, your inputs, whatever you have for me, just drop that in the comment section and I'll be right there with you. Remember to follow my channel, like, subscribe, share this to your friends and classmates, and you can also send me a message. I'll drop a link in the video description where you could send me a message if you'd want a question to be solved, because this question was actually presented by a student. So usually that's how we do it. You send in your questions, I solve them, and then I post them in my channel for you all to watch, learn, and enjoy. So thanks for watching. I'll see you in the next video.